This is the video for section 4.3 notes, slide 13 through 16. All right, so in section 4.3, we're talking about something that I refer to as the first derivative test. All right, so this is basically understanding what the sign of the first derivative tells us. All right, so if f is defined for all x in some interval I, and let x1 and x2 be in I, then f is increasing if f of x sub 1 is less than f of x sub 2 for x sub 1 less than x sub 2. So all we're saying here is that if I'm moving from left to right, so here's x1 and here's x2, f of x sub 1 is less than f of x sub 2. So in other words, f is increasing, right? Now, what we can say in calculus is that f prime of x1 is greater than or equal to 0 for all x. All right, so f prime is positive, right? So positive f prime means f is increasing, right? All right, f is decreasing if f of x1 is greater than f of x2 for x1 less than x2. So once again, now if we're moving left to right, so here's x1, here's x2, now our y values are going downwards, right? So that also means that f prime of x1 is less than or equal to 0 for all x. So once again, if f prime is negative, then that's going to tell us that f is decreasing. All right, now f is constant if f of x1 is equal to f of x2 for x1 less than x2. So now as I go from left to right, then we can say, well, that all of the y values should be the same, right? Or in other words, we can say that f prime of x1 is equal to 0 for all x, not just at one particular moment. So for instance, let's say I have a graph like this, right? Okay, and I'm going to say this is A, B, C, and D. All right, so what can we say is going on from A to B? F is increasing, which means f prime is positive. All right, but now at B, f prime would be equal to 0, but that does not mean that f is constant because there is only one point, right, where f prime is 0, but not for all x in some interval. All right, B to C, f is decreasing, which means f prime is negative. C, once again, f prime is 0, but it is only at a singular point, not multiple points in a row. All right, and then, of course, C to D, f is increasing, therefore f prime is positive. So that's what we want to understand about the first derivative test. All right, moving on to slide 14. All right, so now suppose that f is continuous on the closed interval a to b and differentiable upon the open interval a to b. If f prime is greater than 0 for all x in a to b, then we can say that f is increasing, right? If f prime is less than 0 for all x in a to b, then f is decreasing, right? So if there is a continuous and differentiable section, right, then a positive derivative must tell us that f is increasing, or a negative derivative must tell us that f is decreasing. All right? All right, so now the first derivative test for finding local extrema. All right, let f be continuous on the closed interval a to b, and c is in between a and b. Now, notice it says let f be continuous, but it does not say differentiable. So that is an important fact that we'll come to in just a moment. If f prime is less than 0 to the left of c, and f prime of x is greater than 0 to the right of c, then f of c is a local minimum. All right, so let's draw this little curve here. Here's c, right? On the left of c, f prime is negative, right? F is decreasing. On the right of c, f prime is positive, and so that means that f of c, which is the y value, is a local minimum, right? So the derivative changes from negative to positive. Now, notice it does not have to be differentiable, meaning what? We could have a graph that looks like this. There's a point at c, and the derivative is negative, then the derivative becomes positive. F of c is still going to be a local minimum. So it's important that you remember, it must be continuous, but it does not need to be differentiable. Why must it be continuous? Well, what if I had a graph that looked like this, but there was an open circle here? Well, we can't say that f of c is a minimum because there is no value at f of c, right? So that's one place that we can look at it, all right? Or what about if it was like an asymptote? So f prime is negative here, f prime is positive here. So we cannot say that f of c is a local minimum, even though the derivative goes from negative to positive, right? Because there is no point there, right? So it must be continuous, but it need not be differentiable. All right. So now, what about if f prime of c is greater than 0 to the left of c, and f prime of x is less than 0 to the right of c? So now we have this graph, right? F prime is positive on the left and negative on the right. Therefore, f of c is a local maximum. And once again, it need not be differentiable because a positive to negative derivative, as long as the function is continuous, will still lead us to a local maximum. So that's the first derivative test. All right, so now what we're going to be doing is actually looking at some functions. All right, so first of all, we started off graphically. All right, so these are both graphs of f prime. So pay particular attention to what graph you are given. All right, but it says use the graph of f prime to determine the x values where f attains local or relative extrema. All right, so now what I want to do is I want you to think about, okay, kind of like a number line here. All right, so at x equals negative 3, x equals 0, and x equals 4. What can you say about the value of f prime? Well, you can say that f prime is equal to 0, right? So I'm going to draw a little number line. All right, so I'm going to put negative 3 on the number line, I'm going to put 0 on the number line, and I'm going to put 4 on the number line. All right, so now if I'm thinking about the values of f prime, okay, you can say that it is negative, at negative 3, f prime is 0. At 0, f prime is 0. And at 4, f prime is 0. All right, so now, what is f prime to the left of negative 3? Well, remember, this graph is above the x-axis, so f prime is positive. All right, what can you say about f prime between negative 3 and 0? Well, it's below the x-axis, so it's negative. All right, what can you say about f prime between 0 and 4? It is positive. And what about to the right of 4? It is negative. So what do you have going on at x equals negative 3? The derivative changes from positive to negative. So positive to negative derivative must mean local maximum. Okay, at 0, you have negative derivative to positive derivative, so you must have a local minimum. And at 4, you have positive to negative, so you must have a local max. So it says, determine the x values where f attains local or relative extrema. So you would say at x equals negative 3 and 4, there is a local max. Okay, x equals 0, there is a local min. Okay, all right, same thing here. So now I'm going to think about, when is f prime 0? Well, at negative 5 and at, this is like 5.5. I know the picture's not great. All right, so on my number line, I'm going to say, okay, here's negative 5, here's 5.5. The derivative prime is 0 there and 0 there. All right, what is the derivative to the left of negative 5? Well, it is positive because this thing is above the x-axis. Remember, this is a graph of f prime. All right, what is this graph between negative 5 and 5.5? It is negative, right? And then what is it to the right of 5.5? It is positive once again. So what's going on at negative 5? Positive derivative to negative, meaning positive to negative, meaning local max. What is it at 5.5? Negative derivative to positive, so local minimum, right? So we can say at x equals negative 5, local max, and at x equals 5.5, local minimum. All right, so that is evaluating it graphically. All right, so now, okay, what's the next step? Well, now we need to be able to evaluate that analytically. So slide 16, it says find the intervals over which f is increasing and decreasing, and give the values of x for which f has local extreme values. All right, so we're given a function f of x. So how do I know when f is increasing? That means f prime is greater than 0. Decreasing, f prime is less than 0, right? Local extreme, obviously, changing from positive to negative or negative to positive. So what do we need to do? Well, first step is going to be find f prime. All right, so this is a product of two things. So f prime is going to be found by the product rule, x minus 5 quantity squared times the derivative of 5 minus 2x squared. That would be 2 times 5 minus 2x to the first times the derivative of 5 minus 2x, which is actually negative 2, plus 5 minus 2x squared times the derivative of x minus 5 squared, which would be 2 times x minus 5 to the first times the derivative of x minus 5, which is 1. All right, so now what do I need to do if I want to know when f prime is positive or when f prime is negative? Well, the first thing I need to do is I need to know when it's 0 so that I can do a sign analysis. Okay, you should be familiar with sign analysis from pre-calc. All right, so I'm going to set this thing equal to 0. And first of all, I'm going to clean it up. So negative 4 x minus 5 squared times 5 minus 2x plus 2 times 5 minus 2x squared times x minus 5. All right, so now, okay, I have two things added together, so I'm going to try to factor. All right, so first of all, I can factor out a 2. Okay, I've got an x minus 5 squared and an x minus 5 to the first, so factor out the lower power, x minus 5 to the first. I've got a 5 minus 2x to the first and a 5 minus 2x squared, so I factor out a 5 minus 2x to the first. All right, then remaining. All right, I took out a 2 from a negative 4, so I have a negative 2 remaining, and I have an x minus 5 to the first. All right, and then I have a plus. Now I took out the 2, but I have a 5 minus 2x to the first remaining. All right, so now I have 1, 2, 3 things multiplied together to equal 0. So either the first thing, 2 times x minus 5 is equal to 0. The second thing, 5 minus 2x is equal to 0. Or the third thing. Okay, now I'm going to distribute that. So I get negative 2x plus 10 plus 5 minus 2x equals 0. All right, so now, okay, let's solve. The first one, divide by 2, add 5, so x equals 5. The next one, subtract 5, divide by negative 2, so x equals negative 5 divided by negative 2, so 5 halves. All right, and then the last one, negative 2x minus 2x, that's negative 4x plus 15 equals 0. So I subtract 15 divided by negative 4, x equals negative 15 over negative 4, or 15 fourths. All right, so now we have just figured out where f prime is equal to 0, right? In other words, I figured out the critical numbers, right? Remember, critical numbers are where the local mins and maxes could occur. Now, notice here there are no endpoints, but remember, endpoints are not locations of local mins and maxes. All right, so now what I want to do is I want to figure out when f prime is positive and negative. And so in order to do that, I need to do a sign analysis. So I need to put my 3 critical numbers on a number line, all right, in the appropriate order. All right, so 5 halves, remember that's about 2.5, or that is 2.5. 15 fourths, right, remember is 3 3/4. So I'm going to put 5 halves, then I'm going to put 15 fourths, and then I'm going to put 5. All right, so now on the side, I'm going to put my factors. I have 2 times x minus 5. I have 5 minus 2x. And I have negative 4x plus 15. All right, so now I have 3 rows in my sign analysis. All right, so now on the top row, okay, I'm going to put a 0 above 5. On the middle row, I'm going to put a 0 above 5 halves, and on the bottom row, I'm going to put a 0 above 15 fourths. So now on the top row, pick a number to the left of 5. How about 4? 2 times 4 minus 5. 4 minus 5 is negative 1 times 2 is negative, right? So remember, I have these intervals. All right, then to the right of 5, okay, like 6. 2 times 6 minus 5. 6 minus 5 is positive. 1 times 2 is positive. All right. Next one, pick a number to the left of 5 halves on the middle row. So how about 0? That's really easy. 5 minus 2 times 0. That's positive. All right, pick a number to the right of 5 halves. How about 3? 5 minus 2 times 3, 5 minus 6 is negative. All right, bottom row, 15 fourths. All right, so pick a number to the left of 15 fourths. How about 0? Negative 4 times 0 plus 15. That's positive, right? All right, pick a number to the right of 15 fourths. How about 4? Negative 4 times 4 is negative 16 plus 15 is negative 1. So I put negatives here. Now remember, you are multiplying together the factors. So to the left of 5 halves, negative times positive is negative. Between 5 halves and 15 fourths, negative times positive is a positive. Okay, between 15 fourths and 5, negative times negative is negative. And to the right of 5, positive times negative is positive. And so, what do we know about the original function from this sign analysis? Okay, we know that if the derivative is negative, then positive, there must be a local minimum at 5/2. Okay, if the derivative at 15/4 changes from positive to negative, we know there must be a local max. And at 5, if the derivative changes from negative to positive, there must be a local minimum. All right, so the first part of the question said, when is f increasing? So f is increasing when what is true? When f prime is positive, right? So look at the sign analysis. F prime is positive on the interval 5/2 to 15/4. Okay, I use parentheses, do not include those because that's where the derivative is 0, right? That's where it's changing. All right, what about f is decreasing? F is decreasing when f prime is less than 0. So what would that mean? To the left of 5/2, so that'd be from negative infinity to 5/2. Oh, I guess I forgot the other part when f prime is positive. That would be to the right of 5. So that would be from 5 to infinity. All right. And then when else is f prime negative, that would be from 15/4 to 5. So we would say 15/4 to 5. All right. And we can use like the union symbol to show, the union of those two intervals. All right. So that's when f is increasing and decreasing. So then we also need to talk about local mins and maxes. So we could say at x equals 5/2 and 5, there is a local minimum. All right. And then at x equals 15/4, there is a local max. All right. And so that's a lot of work, but the vast majority of that work is old work from pre-calc. So you got to keep working at it. All right. So that is using the first derivative test.